Good morning, all of you. Today we are going to solve the examples of the chapter Work and Energy. Okay, so now we will see first example. What is given in the example? An electric pump has 2 kilowatt power. How much water will the pump lift every minute to a height of 10 meter? Okay, so when we are solving the example, so first thing we have to see that what are the given parameters and what we have to find. Okay, so now in this case we have to find how much water, means the mass of water we have to find. Okay, so we will write first given power is equal to 2 kilowatt. Okay, now see here we cannot take this 2 kilowatt in the this calculation, because we know that it should be converted into watt. So we know that 2 kilowatt is equal to 2000 watt, and the time is given 1 minute. Okay, so time 1 minute is equal to 60 second, and the height is given 10 meter. Okay, now we know the formula for power, that is power is equal to work upon time. Okay, so this is the general formula for power. We can write power is equal to P is equal to work is W upon T. Okay, but we also know that W is equal to mgh, because we know that this is the formula for potential energy. So as already we have seen that energy is as good as the work. Okay, so we can write W is equal to mgh. Now put the value of W in this formula, so we will get P is equal to W is mgh upon T. Now we got the values of all this. Okay, so power is given 2000 watt. We are writing 2000 is equal to M. We had to find M as it is, into G is value is 9.8 into H is 10 meter, and already we have seen, upon T is 60. Okay, so we have written. Now we can cut this 0 in numerator and 0 in denominator. So we will have the value in this manner. 2000 is equal to M as it is, into 9.8 into 1 is 9.8 upon 6. Okay, now do the cross multiplication of this. 2000 into 6, this it will go in the numerator, is equal to M as it is into 9.8. Okay, now multiply this. 2000 into 6, that is 12,000, is equal to M into 9.8. Okay, now I will write now 12,000. This 9.8 will come in the denominator, is equal to M, or I will write, I will just make the change this statement, this adjustment. M is equal to 12,000 upon 9.8. If I remove this point from here, so again 10 will be added in the numerator. Okay, so just divide this 12 lakh. Okay, 12 lakh from 98. So we will get the answer. M is equal to 224.5 kg. Okay, so just you have to do the division of this from this. Okay, so we got this. So the mass of water is 1224.5 kg. Okay, now come to the next example. What is this? In this, if a 1200 watt electric iron is used daily for 30 minutes. Okay, so what we are doing, we are using the electric iron having the power of 1200 watt. Okay, so we are using for 30 minutes every day. So how much total electricity is consumed in the month of April? So we will see now how many days are there in April. 30 days. Okay, so we will calculate now how many units are consumed in the month of April. Okay, when we are using the iron for 30 minutes every day. So we will write now what are the given entities given? P is equal to 1200 watt, T is equal to 30 minutes. It is every day it is used 30 minutes, so we have to make the this unit same. Okay, so 30 minutes we cannot take, so 30 into 60, because we know that in 30 minutes how many seconds are there. So we know that 1 minute is equal to 60 seconds, so that will be multiplied by 60. So we are getting 1800 seconds. Okay, so now these watt, this is in second. Now we will see now days in April. We know that that is 30 days are there in the month of April. Now we have the general formula for power, that is power is equal to work upon time. Okay, so this we got. Now we have to calculate that how much energy has been utilized. Okay, or we can say first we will calculate this work done. Okay, work done is nothing but the energy used only. Okay, so we will calculate for 1 day. First what we will do, we will find for 1 day how much energy or work done is there. Then after that we will find the energy or work done for 30 days. So for 1 day the work done is equal to work is equal to, we can now cross multiply P into T. We know the value of P, that is 1200, into T is 1800 second. Now we can, if you multiply this, so we get 1 2 3 4 zeros are there. If you multiply 12 into 18, that we are getting 216, that is joule. Okay, so then we got the joule per second. Now next we will calculate for the energy or work done for 30 days. Now work done for 30 days, that will be work done is equal to, now one day we have calculated the work done for 1 day. Now just multiply this figure into 30, and that this we will get 648 0 0 0 0 and 0. Okay, if you multiply this, here we are having 40, here we are having 10, so 50 as it is. And if you multiply 216 by 3, so we will get 648 joule. Okay, so this is the actually this is in the joule form. We got the work done in joule form. Actually we want to find it is in units. Okay, so we know that in, as we have seen in the this when we were explanation was there, one unit is equal to 36 lakh. Okay, one, or we can say 36000000 joule. Okay, one unit we are having this much value joule. Okay, now we are having this much value of joule. So what we will do, so how many unit will be in the this 648 0 0 0 0 joule. Okay, so just divide this figure by this in 1 day. We know this sorry, in 1 unit how many joules are there. So just divide this figure by 1 unit joule. Okay, so we will get the how many units are there. So just see here, 0, this will get cancelled, this one, this will, so all the zeros will get cancelled. Only we are having now 648 upon 36, and if you divide this figure, so we are getting 18 units. So the consumption of the energy, that will be 18 units in the month of April. Okay, now the third example, what is that? Let's see, in this case, if the energy of a ball, okay, falling from a height of 10 meters is reduced by 40%, how high will it rebound? Okay, so what we have to find here, if the energy is in one ball is there falling from a height of 10 meter. Okay, so is reduced, its energy is reduced by 40%. So how high will it rebound? Oh, it will jump. Okay, so we have to find. So we will see now. Actually I have shown here, or I will let the here no given quantity entities are there much. So what directly we will see, directly we will solve the example. Now let the ball rebound at height h. Okay, consider that the ball rebound at height h, and the height is h is equal to 60% of the energy at height of 10 meter. Okay, So just you can see there, zero, that ball has been, height is was given, this is the 10 meter. Okay, so when it has been rebound, height was the ball was thrown from the height of 10 meter. Okay, so how much it will jump, okay, rebound, when the 60% of energy has been taken out. Okay, so we will see now 60% of 10 meter we have to find now. Just consider that this 10 meter is 100% that value. Okay, so we can write this 60% of 10 meter. We can write 60% means we know that when we are telling 60%, 80%, whatever, it means that we are getting that out of 100. Okay, 60% means 60% of 100. So I have written here 60 upon 100 into 10. Okay, now just simplify this, 60 into 10 upon 100. So it will become, or we can just this 0 will get cut this with the 0, this 0 will get cut with the 0. So the remaining is 6 into 1 upon 1, and that is answer is 6 meter. Okay, so we can say that the ball has been rebound up to the height of 6 meter. Okay, now the fourth one. Now the velocity of a car increase from 54 km per hour to 72 km per hour. How much is the work done if the mass of the car is 1500 kg? Okay, now we know that the work done formula, also we know that this velocity related formula. So we'll see now. Now what is given in this example? Given is the mass, m is equal to 1500 kg. Okay, now initial velocity, that it has been told to us that the velocity of car increase from 54. So we can consider that 54 kilometer is u is equal to 54 kilometer per hour, and v is 72 kilometer per hour. Okay, so from this formula we have to find. So we will write this as initial velocity is equal to 50 kilometer per hour. Okay, now it is given in kilometer per hour. Actually we want this to be converted in meter per second. So what we have to do here, we know that 52 into 1 kilometer is equal to 1000 meter. Okay, so I will write here 52 into 1000 upon hour. We know that 1 hour is having 60 minutes, and the 60 minutes, 1 minute is equal to 60 seconds. So we will convert this in second. Okay, in this manner. So I will write this 54 as it is into 30 or 1000 upon, multiply this 6 and 60 into 60, that is 36. So if you simplify more here, so we will get this 50,000 upon 3600. So this 0 will get cancelled with this one with this one. Okay, now 540 is remaining upon 336. Now that will be, if you just simplify this, we are getting 15 meter per second. Okay, so all what we want, we got this. Now second, we have final velocity, that is v is equal to 72 kilometer per hour. Okay, so again we have to convert this in meter per second. So again we will utilize the same method here, 72 into 1000 upon 60 into 60, that is 72,000 upon 3600 is equal to, just we will simplify this again, cut two zeros, this 0, this 0, this 0, this 0. Now 72 upon 36 is remaining. If you just simplify this, we are getting 20 meter per second. Now we got this two for that values, u value and v value. Now as we know that already we have seen that work done is equal to change in kinetic energy. Already we know this change in work done is nothing but the kinetic energy only. So that formula is, we know, half m into v square. Okay, now here no, the directly velocity is not given, but change in velocity is given. So I will write half into m into, now this will be v minus u, final velocity minus initial velocity up into square as it is. Now half into, now put the value of m, that is 1500 into what is the value of v, already we have seen, that is 20. minus 15 whole square. Okay, just if you simplify again, half into 1500 into, if you just make the square of this, that will become 400 minus 15 square of 15, that is 225. Then half as it is 1500 as it is into, if you minus this, so we are getting 175. Again what we will do, half into multiply this term, so we are getting this 262500. And if you divide it by 2, this whole this number, so we are getting 131250 joule. Okay, so this is the answer. Now the last example is there. What is that? Ravi applied a force of 10 Newton and moved a book 30 centimeter in the direction of the force. So actually that book is in the direction of the force only, so that is a positive work. How much was the work done by Ravi? Very simple. What are the given entities here? Force is given 10 Newton, as displacement is there 30 centimeter. So we know the formula, work is equal to F into S, force into displacement. Put the values here, 10 as it is into S is value 30 centimeter, that is, so we got 300 Newton per centimeter. But we know that we want this in Newton per meter. Okay, so what we have to do, we have to convert this in Newton per meter, so we have to divide it by 100. So I am dividing 300 upon 100, that this 0 will get cut and the answer 3 is remaining, so answer will be 3 Newton per meter, or 3 joule is there. Okay, so this is the answer. Okay, hope you understood this all the examples. Thank you.